Good evening. Welcome to Chapter 15 of CS 1030. This is the second portion of the programming. The previous chapter we talked a high-level overview of what the programming was, getting closer to the metal, as they say, with assembler and C, and then high-level programming languages. This time we're going to talk about actual programming itself in Java, a little bit in C++. And this is, again, to get your feet wet. This is by no means an in-depth programming discussion. And if this does interest you, I suggest you take CS 1400, which is the programming in Java. And there's some OOP courses as well. This is where I really enjoy spending my time in IT, is in programming, and it's something that I do on a daily basis. And so let's dive in. So in this chapter, we're going to just get, again, a high level. I want to stress this is a high level programming language. And we're going to use Java and C++. Now, there are other programming languages out there. For instance, C# from Microsoft, which is a very strong programming language. And also Python, which I want to take a second and discuss. Python is a great language for people to cut their teeth on development. It's easy to learn, it's easy to understand, and yet it's extremely powerful. A lot of people who are getting into artificial intelligence and getting into data scientists are using Python for their language of choice. Again, that's a great way to get in. There's a high demand for both AI and data scientists, if that's something you enjoy. And if so, I suggest looking into the Python arena for that. But not just for those two things. Python is great. It's great for developing IoT, which is smaller devices like Raspberry Pi and Arduino. And it's also down to what they call Python on chip, which is very small processors, which you can write a Python program, put it on the chip, and have it start working. It's a really great language. C# is another great language. It's what I like to program in, and it's what I do a lot of programming in right now. It's just as powerful as Java. It's a great development environment using Visual Studio. So although we are going to talk about Java and C++ in here, understand that what we learn in here can apply to other programming languages. And we talked about in the last chapter how really programming languages is like learning a foreign language. Once you get the syntax down, the fundamentals are really the same, like variables and other decisions like if-then statements. They're all part of the programming language and part of the programming atmosphere, or ecosphere. But it's the syntax that changes slightly. And that's where, once you get a foundation and an understanding, especially in like object-oriented programming or OOP, the language of choice that you use can be dictated by a number of things. A lot of times, people who get in electrical engineering will be in lower levels like C and assembler. Other developers use Java because Java is one of the #1 programming languages out there. Again, like I talked about, Python is AI and data scientists, but it's also used for everyday programming. And then C# has a wonderful support from Microsoft. It's a great programming language and a great development environment. They've gone a long ways to making it so now that you can, much like Java, you can run C# just about on anything, Windows, Mac, and Linux. So, although I'm not here to tell you which language is the best, go out and explore and see which one appeals to you. Sometimes it's dictated by work, and they say this is what we're going to use. Other times it's just deciding that you want to learn a new language. Some languages have advantages over others, and that's outside the scope of this class to get into, but you do need to understand that not one language is better than another language necessarily. There used to be knockdown, drag out brawls over this, and really the language that you specialize in is going to be the language that you love. Now I know that kind of sounds funny, but really the first language that you really cut your teeth on and all of a sudden things start clicking is the language that you're always going to have a fond memory of, whether it be Java or for some of us old Visual Basic, or even older people who still I talk to in this industry still love COBOL. I was reading an article just last week about COBOL developers. COBOL developers are in great demand. There are thousands of open jobs, and there's actually a school in New York specifically for COBOL. So, it's fun to use the newest languages and newest and greatest bleeding edge technology, but understand there's still a lot of demand out there for some of the older languages. So again, we're just going to cut our teeth on the different structures in this Java and C++. Will apply to other languages, but just kind of pick up where we finished on chapter 14. There is no one best language for you. So, what do you need to know? Well, this first one, it's pretty self-evident. Time, money, and effort goes into learning a computer language, and it's come a long way. It used to be that to learn a programming language, you had to either buy a book, go to a lot of college classes, maybe pay for some really expensive training. And a lot of times what happened is you'd get into those classes and you would learn some things, and as soon as you walked out of the class, you lost about 90% of that information because it either wasn't pertinent to what you need to do at work or because you didn't put it into practice right away. Well, things have come a long way. There's a lot of sites out there, some that are paid, some that are free, that help you learn the language of choice. But this second bullet point here is, I cannot stress this enough, that the only real way to learn is practice, practice, and more practice. So now you got to think about, well, what does that mean to practice, practice, practice? Well, that doesn't mean you go in and just copy programs that people have out on a website over and over and over. You're really not learning the language. You're learning to parrot or mimic the language. The best way to find out how to program in a language is to come up with a real-world problem that you would like to provide a solution for. It doesn't have to necessarily be something you're paid for. It could be something that you do at home or something you want to do to automate your life. I found that if you try to just learn a language with no real intent or purpose to put it into use, that you quickly forget that language and that syntax. So try to find a solution or a problem and apply a programming solution to it is the best way. If there's nothing that comes to mind, there's a lot of what they call user groups out there that you can join, and there are what they call mob programming. That you can go in and say, hey, I'm a novice programmer, and a lot of times they'll give you basic tasks that you can do, and you can help develop in an open source community that way. Now, I will tell you, there are some open source communities that everybody thinks that everybody should be an expert, but there are a lot of teams out there that are willing to help people learn. Check at the local university. A lot of times you can find these groups and say, hey, I want to learn. I'm a novice. If you're lucky enough to get into a programming position early or into an IT position, may not be a developer, and raise your hand. The very first program I ever wrote, I was doing tech support at a company called iOmega, and I had a lot of downtime because I was supporting the old archaic hardware. And they needed a program and asked if anybody could develop a program to just help keep track of people who call in and ask for information because their old system was going away. And I was bored and it interested me, so I raised my hand, and I said, I'll do it. I'd never programmed before. Quickly went down, bought a book called VB3 for Dummies, was able to get a hold of the software, and I wrote my first program that way. And that's what got me excited because I built something that was actually capturing data and it was exciting. So whatever you can do, try to find a purpose to program. It says after reading this chapter, you must sit down at the computer and practice the concepts frequently. And it's so much easier today. There's so many free development systems. Visual Studio Code is a great way to be able to program in Python and C++ and Rust and Swift and C#. Just about any language has a plugin for Visual Studio Code, and it's free. Visual Studio also has Express editions. A lot of other programming IDEs have free editions now that you can download with tutorials that you can walk through. So there's really no barriers in place to be able to start programming. So how do we choose a programming language? Well, the first one is pretty critical. It seems to be fairly easy, but a task to perform. Well, again, like I was saying, with electrical engineers, these guys, their tasks to perform have to be as close to the metal as possible. So they may choose to use assembly or may choose to use C because they need real-time monitoring. C++ is a good language for more real time because it's truly compiled. As you remember in the last chapter, a compiled language is able to go from PC to PC, let's say, using an Intel chipset and run without any external support needed. Where Java, Python, C Sharp, those are all interpreted languages and they carry extra baggage with them in order to translate the code down to machine language instead of compile it. So there's a lot of things to consider on the task and your programming skill level. There are some programming languages that are easier to learn than others. Um, like I mentioned, Python. Visual Basic was pretty easy to learn. These languages use more of a familiar syntax and less of a shortcut type of language, like C Sharp, Java, and C++. Maybe a little bit more intermediate to advanced. What's the program's lifetime? This is something to consider. There are projects that I've worked on where we use this language that came out that was greatest, and it was incorporated into this software, and it was a scripting language, and it was this proprietary scripting language that we were told was the neatest and greatest thing to get this software to extend it. And the program's lifetime, it's, as far as I know, still running today, 10, 15 years later, and the software is unsupported now. The company has gone out of business. And so one thing to consider in a project lifetime is how long has it been in use, what's the support, whether it be community or by companies. That's something to consider as well. And then, of course, the software complexity being designed. Some of the higher level languages, like Java, C++, lend to more flexible architectures, a little bit easier. And so if you're looking to develop, say, a small Hello World program where somebody clicks a button and it says Hello World, you may not have to get into real low-level programming. A high-level language might be just adequate for something as a small repetitious task like that. Whereas if you have an enterprise system that does a lot of communication with external components and programs and external hardware translations, then you're maybe looking at something a little bit more complex and robust like C++. So C++, Java, and when I talk about these things, it also applies to Python as well as to C Sharp, but they're object-oriented. C++ came along because C was more of a procedural language. It did not have any object-oriented capabilities. Again, remember, object-oriented is you have an object that has properties, methods, and events. C did not support that. C++ was developed in mid-80s or so to support a more object-oriented aspect for development. Java also came along and supported that as well, and then later C Sharp and Python. Now there are scads of languages out there like Swift and Rust that do support object-oriented. So that's one thing to look at when you're looking at your programming language, to decide, do you need the overhead of object-oriented, or is a scripting or procedural type language like C better suited for you? The nice thing about Java, C++, and C Sharp is you can use them on different operating systems. Right now they'll run on Mac, they'll run on Linux, different flavors, and they'll run on Windows, of course. And so if you look at that, the promise of Java and C Sharp now is theoretically you can write the code in one environment, say Windows, and then it is compiled to be able to run on a Macintosh or a Linux box. C++ is a little bit different. You're going to write code more to a specific platform, and then it's going to be linked and compiled for that platform, but it still will run on multiple systems. It gives you a strong foundation for learning how to program. Now, my recommendation here, although the book says C++ and Java, I would say that instead of focusing on C++, unless there's a real need for it, is maybe look at Java, Python, and C Sharp to get a good foundation. They're a little bit more friendly, a little bit easier to use, and widely supported. And then, of course, with Java, C Sharp, and Python, it says it's a springboard to other languages. Well, what that means is understanding the foundations, like we talked about in the previous chapter, and then taking those concepts like variables and constructs and the idea of decisions, and OOP, and getting that foundation in a language that's a little bit more user friendly, and then taking that and taking those concepts to other languages that you may have to learn the syntax, but you still have a good foundation to build on. So, what's our 4 favorite ingredients that we're going to talk about? And these are what I've been talking about. We talked about it in chapter 14 a little bit. We have our variables, our operators, our control structures, and our objects. Our variables, all programming languages have variables. Otherwise, we talked about in the previous chapter, programming would just be miserable. Operators are pretty much the same. Your add, multiply, divide, etc. are all pretty close to being the same, and as all the languages that I've ever dealt with, they all have the same order of precedence. Remember, we talked about in the last chapter, order of precedence can determine the outcome of a number based on whether you use parentheses or not. And just like in math, multiplication, division, execute before addition and subtraction. So that's the same. Control structures are usually the same. If-thens, while loops, do loops, for loops, etc. All of these concepts we're talking about, again, we're building on the foundation from chapter 14 so that we can then take it and put a syntax to it and start creating our program. And of course, objects. Remember, object-oriented programming, properties, methods, and events. Generally, they're a class, but an object for object-oriented programming has properties, methods, events. And remember, object-oriented programming is inheritance, polymorphism, and encapsulation. So these are high-level languages, so you don't have to worry about getting down into the ugly ones and zeros. But with C++ being compiled, it has a tendency to execute faster than Java does because it is compiled and not translated. There's not that extra step to go from the intermediate language down to machine code. So if you're looking to write systems that are more what they call real-time or critical systems that depend on information being processed extremely quickly, then C++ may be a better choice than, say, Java or C#. So let's talk about this. It's designed, came out from a company called Sun Microsystems, which has since been purchased by Oracle. It was open source from the very beginning, and it was around 1995, and as it says here, it was designed for the internet use. Internet was just starting to take off, and when we say internet here, this is the web. The internet's been around, we talked about way back at the beginning of the class. It's been around since the late 50s, early 60s in DARPANET. So when they say internet here, they're talking really about using the internet and web pages and the internet protocol TCP/IP for kind of making a larger network. So I just wanted to qualify that. It started taking off in Java and C# as well, but they have what they call, in Java it's a JVM. It's a Java virtual machine, which in theory you can write the same Java code, then that Java virtual machine will take it and translate it to the appropriate CPU, whether it's Windows, Macs, Linux, but you'll also notice for small appliances. And also for a lot of smaller interfaces, microwaves, CD-ROMs, a lot of these smart TVs, although they may be going more to Linux, use Java as a basis for creating the UI. And so it's a flexible language. Billions and billions of components or devices run Java. It's a very popular programming language, and it's not going anywhere. But they have it, it's the big thing here is it's intended for small tasks or applications. Now that has since been a little bit expanded. Languages like C# and Java now, with the systems being so fast, and they have an ecosphere or struts or applets that you can bolt on, that there are applications now that are released in Java that are enterprise capable. One of the ones that comes to mind is it's a graph database called Neo4j that's written in Java. So Java is Now a full-blown programming language kind of grew up a little bit, and like it says here on the slide, PDAs, which I keep in there because I love them. PDAs kind of don't exist anymore, but cell phones, internet networks, there are some network appliances that run Java as their interface. And it is fully mature. Enterprise systems run on it, and it's a great programming language if that's where you want to go to learn. There's no shortage of Java jobs out there right now, and good Java developers can command a pretty good price in the market. So the big advantages is a familiar syntax. It's a C type syntax. Now I do want to say that Java and JavaScript are not the same. They call it JavaScript because it kind of looks like Java, but Java kind of looks like C. Java kind of looks like C sharp. So when it says it's a familiar syntax, if you've programmed in C or any of the C-type derivative languages like Object-C or Swift or whatever, you'll notice that there's a familiarity there with that syntax, but it is portable. Theory being that you can write a Java program on, say, your PC and take that Java code and go run it on a Linux or a Macintosh or even smaller devices, depending on how you develop that, with little to no changes necessary. It's powerful and it is popular. Now, C++, again, 1983, from Bell Labs, and what they kind of got this concept of OOP and said, well, C is a very strong language. It's compiled, it runs great, but it's lacking. We really need to be able to kind of update this language and make it so it supports OOP. So what it is underlying it's the C language, but it is object-oriented C. And it gives you, it says here, simplified memory management, but it also gives you access to low-level memory. Now, Java, Python, C Sharp, those languages really don't give you low-level memory access like C and C++ do. So again, do you need to have control over memory management to fine-grain detail? Some programmers do. If you don't, then, not saying you can't use C++, but just understand that that option is there, so you may need to be a little bit more careful how you release and free up memory if you decide to get down into those ugly waters, I should say. A language, or I mean a pretty famous program that was run on C++, I know during the late 90s, was on Microsoft C++, actually, was Oracle, their competitor database. I know that's since been switched, but there's a lot of programs out there that run C++, and there is a huge demand for good C++ developers. So let's talk about a variable. Now, a variable, let's talk about a variable outside of programming. Let's just talk about the word variable for a minute. What a variable is it's a placeholder that allows to hold different objects, different strings. It could be different integers. It could be really anything that, depending on what you want, variates from one call to the next. And that is what they call a variable, like in math. I remember the first time I saw solve for x, 3x plus 2 equals 7 or whatever. That variable there was x. It was a placeholder. And then you needed to find out, how to solve for x and what that variable was. So it has specific effects on the program's outcome. Without a variable, like I said in the last chapter, imagine trying to write code to deposit money into a checking account from just $10 to $20, and without a variable. You would have to write a bit of a same piece of code for $10, for $10 a penny, for $10 2 pennies, etc., all the way from $10 to $20. And you can quickly see how it becomes unwieldy. And so a variable allows you to put a placeholder. It's generally given an identifier or a name that is a little bit more human readable. And when you create that variable and declare it, You give it a name, a type, and then you can add some content to it. So let's say, for instance, we have a shopping cart, and we have a variable in there called shopping cart total. Well, every time you go through there, it is possible and most probable that your shopping cart total is going to change based on what you put in the shopping cart, based on taxes, based on maybe discounts. There's a lot of things that make it change. And so that variable called shopping cart total, you say I want to hold a float or you want to hold a decimal value. And so what happens behind the scenes is the program will create a place in memory, and that place in memory will have a name you associate with it called shopping cart total. So you don't know, unless you're in C++, but in most of the high-level languages, you don't know where that's stored in memory, nor do you care. All you know is that you read and write the variable based on the name that you gave it. And so it's important as you're creating variable names to use names that make sense, like shopping cart total, instead of X or 123 or some other obscure name that you have to keep going back and looking to see what the name is. Also, it's important that when you create a variable that you give it the right type. Whether it's a character or a string, for instance. A character will hold a single character in it. And that may be all that you need. You may not need to declare a string variable just to hold one character. And that comes with practice, and that comes with intuition as you're developing of creating the correct type for that variable. So example here on the bottom is they're going to give it a type, and in this case it's an integer, int. And then here's the name. It's num tickets bought. And now to reference this integer, to add or subtract or to read what's in there, for instance, you don't care what this num tickets bought memory location is. You just know that you need to refer to num tickets bought. And then further down the code, or you might write the code and come back a couple months later and inevitably forget what you did. Imagine if it said int x. Well, what does x mean? Where if you look in the code and say num tickets bought, you can say, oh, it's most likely the number of tickets bought. And without even looking at the declare here, where it's an integer, you can infer from the name that it's a numeric value. So there are some variable naming conventions. Let me preface this whole thing by talking about naming conventions. Naming conventions, there have been just over the years some naming conventions that have just kind of been defined and people kind of follow as a guideline. However, there are some companies that I've worked at that have their own naming conventions for one reason or another. So when you have a variable in here, when we talk about the naming conventions here, we're not going to go into that. We're going to talk about how to create them. So names can be letters and underscores and numbers. Generally, you cannot have a space in any sort of a variable, and there are some rules that are specific for programming language, but all in all, use letters, underscores, and numbers. The variable in all the languages I've ever programmed with, it says must begin with a letter. However, it has become commonplace in some places to allow a variable name to start with an underscore, and that usually has a specific meaning within the programming language or within the conventions that are being used, but you can use an underscore to start off. But normally you're going to start off with a letter, and then you can use a number afterward. The big thing here on avoiding the reserved words. Now, in every language there are reserved words, or words that the programming language uses to identify some sort of a function, or is used within the programming language for a specific purpose. For instance, loop. You wouldn't want to call a variable loop because in these programming languages, loop is a reserved word, and you cannot use them for a variable. Some languages allow that, but it gets very confusing. So as a general rule, if you're using an IDE for development and you try to create a variable and you give it a reserved keyword name, Generally now the development environments will throw up an error saying, hey, you can't do this. But in case or if you're not using an IDE, because you can write this code in Notepad, for instance, avoid reserved words. What are those reserved words? Well, if you go out to the internet and do a quick search for Java or C++, C#, Python reserved words, you'll get a big list. So now we have types, and most programming languages, with the exception of Python, are strongly typed, and that means that you have to declare the type before it's used. Python and JavaScript don't follow that. They allow you to create a variable, and then depending on what you store in that variable, then the type is inferred from that. But all in all, when you create a variable, you need to give it a type, and that's what it's called, strongly typed. So that way, if you have a variable that is an integer and you try to stuff a string or a character into that, it's going to throw a syntax error. The major data types, there's 6 number related types, usually like integer, decimal, float, etc., large, big, int, tiny int. There's one character related, which is a string, because a string is really an array of characters. And then you have Boolean, which is true, false. Big difference here between C++ and other languages is you have a type for signed and unsigned numbers. And that's a big difference. So an unsigned number is only positive values, where a signed can be positive or negative. So for example, an integer value usually holds anywhere from 0 to 2 billion something in there for a 32-bit integer. In C++, if it's unsigned, then it can only hold positive, whereas in C# and Java and other languages that don't have signed or unsigned, you can store minus 2 billion to positive 2 billion. And again, to declare a variable, you give it a type and a variable name. So integer data types are for positive and negative whole numbers. Now, when you start developing, it's important to understand that with an integer type, like an integer, this is usually 32 or 64-bit depending on your system, short, long, and byte. These will hold positive and negative numbers. If you try to stuff a decimal into an integer, if the language allows it, it will often truncate it. Sometimes it will round it. There's rounding where you can round up and round down. There's a lot of little intricacies in there that you have to be aware of. So if you're working in whole numbers, use integers. If you're not, then use the appropriate data type. And you'll notice here on the bottom we have int and short. You'll notice it's the same here, but then you have an unsigned integer total points, meaning that it can only be positive. There are no negative numbers. If you try to stuff a negative in here, oftentimes it will give you a compile error, or it will give you a runtime error, meaning that it compiled just fine, but now you're trying to stuff a negative number in there and it can cause a crash. So here's the equivalence. Notice that integer is 4 bytes and it's minus 2 billion to positive 2 billion. A short is minus 32 to 32. And a long is 8 bytes. And I'm not even going to try to determine what that is. It's a pretty big number on here. And then you'll notice a byte is minus 128 to 127. Well, why isn't it minus 128 to 128? Because in this case it's minus 128 to negative 1 and then 0 to 127. So that's just a little bit tricky. You need to kind of keep be aware of. Now if you have a byte that's 128 and you decide that you're going to stuff the number 129 in there, you'll get an error because that variable isn't set up to hold that size. So you need to size your variables accordingly. Well, you can just make everything long and hope for the best, but if you're using numbers in there that don't have to go up to there, there's no reason to consume memory for placeholders, where if you're going to use a byte, then you use a byte. There's no sense creating a long, because really, when it comes down to it, if you are looking at enterprise-wide systems, you're trying to conserve memory, so you just need to be aware of that. Now, with a integer down here, you'll notice a couple of difference, and that the short is 32 minus 32 to 32, but the unsigned, you'll notice here, is from 0 to 65,535, meaning that you can only have positive values, but because you can have only positive, then you can take this negative amount and really add it to this side. So that's why with an unsigned short, you can store from 0 to 65. You're still consuming the same amount of storage, but everything's positive numbers. And again, with an integer or an unsigned long, you're still using the same amount, but if you don't ever have to use negatives, you kind of effectively double your positive capacity in the same amount of storage. And so that's what's really nice about this as well. So now we have floating point types, and these are again positive and negative, and you can see here like float salary and then double Bill Gates' salary. Again, it just depends on the amount of space that you want to allocate for the size of the number that you're looking to get into that. And there are some things to understand about floats and doubles that are outside of the scope of this class and using the correct type for each one. There's also another one in these languages you could use called a decimal, which is a little bit easier to use if you were going to use like a salary like this. Now you'll notice here that we have two floating points. We have the float, which is 4, and the 8 bytes here. And you'll notice why it's 6 to approximately 7 digits. So that's what this plus or minus 38 float is, what this means. We did double Bill Gates's because it's 15 significant digits. And notice here on a float, it says approximately. And that's because floating numbers are approximate. And again, that's outside the scope of this class, just be aware of that. But float and double are used in scientific all the time, scientific programming all the time. Now down here on the C++, you'll notice you have the float and the double. And then you have this other one called a long double, which is 19 significant digits. So you can see here that initially Java did not have that. Now, of course, these languages do grow and they do change. There are ways that you can create longer, like a long double, for instance, within Java with different classes. But you'll notice here that again, the storage requirements go up by 4, and then 8, and then 16, and 32. You'll notice that they essentially double. So if you don't need a long double and you're not going to use 19 significant digits, use a float or use a double. Again, you're trying to use the correct amount of space that you anticipate you're going to need for your variables. It is poor programming practice to assume you're always going to use the greatest amount of space and program for that, because that's a lot of wasted memory that could be used for other operations. So we have one character type, and a character type will hold a single, and notice here it's in single quotes, and that is something that you need to understand. It's same in Java, same in C#, that a character is designated by single quotes and a string is designated by double quotes. It holds 2 bytes, and you'll notice here that it is for a Unicode, so it can go from 128 on the C#. It can go from -128 to 127. If you use an unsigned character, you can get from 0 to 255 in 2 bytes. Normally, in other programming languages, if you're going to use that for 255, so it's -255 to 2 positive, then you have to use 4 bytes. So again, you can see where C++ gets some advantage here if you're only going to use positive values, to use the same amount of storage to get effectively double the positive numbers for holding. And then there's a bool type, and it's true false. It says you cannot associate a number with a Boolean value, and that has changed. Generally 0 is false, 1 is true, but if you declare a Boolean type, you're going to use true or false. Some languages now will allow you to assume 0 and 1, but really if you're going to use a Boolean, like for instance it says here Boolean in C#, it's bool, in C++ it's bool, C# it's bool. You'll notice here that if it is a Boolean, it says a deserve raise, and that's true or false. Just think of true, false, yes, no. It's one or the other. There's only two values, so in most cases it's true, false. And you'll notice here it only uses 1 byte. There is no unsigned bool. That doesn't make any sense, but it's 1 byte, true or false. And that's because behind the scenes, true or false is stored as 0 or 1, depending on whether or not it's true or false. Now, a string is a little bit more unique because a string is not a number, but it can contain a number. So, for instance, if you declare a variable like this down here, string, and you give it S name, and you'll notice, I want to point out, notice in Java it's a capital S, and notice in C++ it's lowercase s. In C# you can use upper or lower, but those are two different things. It's a string object versus a string variable. Didn't mean to divert a little bit, but just to bring that up. So in these languages, like Python, C#, Java, C++, capitalization is critical. There is a difference between a string or string, so you need to understand what those are. Now, a string is really an array of characters, and it allows you to store more than one character. Like I said, you can create a variable type called a string called sname, and you can store the value 1, 2, 3, 4 in this name, but it has to be enclosed in double quotes. Anything between double quotes is considered a string and will be stored as such. Now, there are some special things to understand about strings. So you'll notice here that you have Joe Blow. You'll notice you have a space in here. You can use punctuation in here as long as it's between double quotes. Anything that's in there is going to be stored in a character array. Now, talked about last chapter about how you have dual purpose operators. This is one of them. It's the plus operator. If your variables are of type integer or math, numeric, then the plus acts like math. 1 plus 1 is 2. If your variables are of type string or character, then the plus will do what they call a concatenation. And that concatenation will join those two strings together. Now, this is where you can get into some subtle bugs, because it is possible in some languages, if it sees that you have a string and you have an integer value and you add the plus to those, it will defer to concatenation. And that may not be what you want to do. So you need to really pay attention your variable names, because this operator here can mean either math or concatenation. So we're going to talk about Hungarian notation for a minute. One other thing about strings real quick. A string is what they call mutable, which means you declare this string here and you give it this name, and when you declare a variable of type string, behind the scenes the programming language doesn't at this point know how much memory it needs to consume in order to store these variables. So it is generally good practice when you declare a variable of a string to give it a value. Now, by doing this, what's happening behind the scenes is this sname is getting a memory reference to a character array containing these characters in it. And then that is what they call immutable, which means that once you declare a string of this type and give it this value, this cannot change. So if you're going to then want to change or add Joe Blow, and then you want to add more values to it afterward, for instance using this concatenation operator and say Joe Blow, and then you decide is my friend, then what happens behind the scenes is it has to create a new variable to hold those characters, copy the value from the old integer, or the old array, excuse me, into the new array and append those characters. Doing that consumes resources and it consumes time, and if you are using a lot of string manipulation, then what can happen is your program can slow down and it can actually crash in some cases. There are certain methods within Java and within C# that you can use, something like they call a string builder, which doesn't do that, but just be aware. The important thing to remember about strings is once they're declared, they're immutable, meaning they cannot be changed. Even though you can change them in the program, doing so comes at a cost. So let's talk about Hungarian notation. This is a naming convention that's being used, and honestly I have not seen this type of notation for quite a few years, excuse me. A lot of times they use what they call, now they'll use camel case or some other naming convention, but Hungarian notation came out and said use the C character, F, I, as you can see here, LI, and just by looking at a variable name, so for instance C middle int, you knew this was a character, you knew this was a float, an integer, a long integer, a short integer, etc. This is becoming less and less of, at least in the programming shops I've been in for the last few years, has become less and less of a standard and is now becoming more and more of a bygone era here. But just to be aware that this does come up from time to time. A lot of times you'll see str for string or txt. So just be aware that if you're going to use a notation, it's not a bad one to use. It's just falling out of favor. So the variable, when it's declared, this is where you need to, again, pay attention. So when you declare a variable, you have to use an equal sign, single equal sign, to assign the value immediately. Now it is possible that you can create a variable and then create the variable and assign it the value, as you see here on the bottom. You can create this int iStudent, and then you can say iStudent equals 456, or you could do it all in one line, and this is becoming more and more of a standard here is to do this. Now you do not have to assign a value immediately, as it says here, because the languages will often give it a default value. So for instance, when we create int iStudentCount, it is given a value immediately as a placeholder in memory by the operating or by the programming language. Most of the time if it's an integer, it's 0. Most of the time if it's a Boolean, it defaults to false, depending on which programming language you use. So understand that you're creating a variable here, and although you haven't initialized it by setting it to a value, it has been initialized with a default value. Now, do not necessarily rely on default values because that can change subtly between languages. So the best thing to do is declare a variable and then, give it a assignment as soon as possible. So a change here, or this is a character, and again, single quotes, and this is the same in all three languages, C#, Java, and C++. And again, you'll see we have a char of C middle int, and then that is equal to a single quote. If you do a double quote in here, I know that if you're trying to do a double quote, that Visual Studio will actually throw an error because it's saying you're trying to assign a string even though it's a single character. So it's important. These are the small nuances that just come with time and practice and learning your development language. So fortunately nowadays the development environments will bring this to light early so you don't try to compile and get a compile error. And again, you can do char and give it a middle int, and then declare that with, in this case, quotes. Now, one thing to keep in mind here, again, this is using that Hungarian notation, that C. Camel case, it would be get rid of this C, use a variable name here that makes sense, like middle init, or call it middle initial, and then the m would be lowercase and the I would be uppercase, and that would signify, just by common convention now, a local variable. And this is falling out of favor, or they might put a char in front of it or something along those lines. Whatever you decide to do, try to stick with that naming convention, whether it's determined by the company or just by programming convention. Again, it comes with practice, 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 as we talked about at the beginning here. So using a string is string, and again, S for the Hungarian notation, and then notice the double quotes. Now, there is a fundamental difference between this variable and this variable. Even though they both are holding a single character, the amount of space consumed by a character is considerably less than a string, because a string is an array of characters, and so it has to set up the overhead of that array. So keep that in mind. If you're only going to use a middle init and it's only going to have one initial in there, then there's no reason to use a whole string for that. So we talked about this before, our control structures: invocation, which is calling an extra method, top-down selection, and repetition. And this will allow for a readable program and easier to maintain program, especially invocation. I want to take a minute and talk about invocation. The invocation is calling out to another bit of code, another class, another function, to allow it to have that multiple classes serve multiple parts of a program without having to repeat the code over and over and over. In Java, you have a main block of code everything starts at. The same thing with C#, C++, it's the main function. And you'll notice that we have this public class down here, but this is the signature: public static void main, and then some arguments that are passed in. And this is the entry point. If you don't have a starting point, then you try to run the program. A lot of times the programming language that you're running in will say, I can't run this, I don't have a starting point. So here we have this main point, and then you can return this value. In this case, we're just kicking something out onto the screen, but you can do some functions down here, and you can return a value back out to the calling function. And what that allows you to do is, if you notice that you're repeating the same code over and over and over, that's a good indication, hey, I may need to stop and make either a class file or a separate function that I can invoke from multiple places. That way, if you have to make a change, you only have to change it in one place, not multiple places. So parameters can be passed in, and depending on the parameters passed in will affect the function of that call, which could return different values. Again, this is where variables come into play. You can pass them in as a value. For instance, here you can do C# hello with the 10 on that, and it will pass this variable in here. And you'll notice here this string arguments here. Because it is command line on the arguments, then you can pass those variables in. So depending on what happens, if you pass in 10 down here in your code, you could say, if they passed in 10, then do this, or if they passed in 20, do that. Again, this is where you get to use variables, which can change the outcome of the program. C# has a main function in every program. And notice that software engineers include other files to perform common tasks. Those are generally DLLs or external classes or Java files that are included, so that you don't have to write the same code or cram it all into one file. And then you could take that code, that extra code as they're talking about here. Those other files can be used multiple places, and often that happens. That's the power of Python right now. Python language itself is pretty basic, but because so many Python modules have been written that you can download and include in your program now, you don't have to write all that code. You could just use the functionality by invoking it and letting those methods do what needs to be done to return the heavy lifting for you. And that's why Python, same thing with Java, same thing with C++ and C#, that's where Java really comes into play. So you'll notice here that C++ allows words inside the parentheses, and it indicates like it follows here in the main like we looked at. So we have this int argc, and then we have a comma, and we have a char of argv, and this right here is a indication that it's an array. So here's the receiving parameter. So you'll notice here that we have a main function, which is what C# or C++ uses to invoke, and then it's expecting an integer and a char value to be passed in. So top-down or sequential programming is more along the lines of C in assembler. It will execute in sequential order. It starts at the top, works to the bottom, and when it gets done to the bottom, it stops. Sequential programming is still valid, it's still used, but it's not as common now because sequential programming can easily turn into spaghetti code, and so it's something that you want to consider when you're looking at your programming language. C is great, it's sequential. It does a great job. It has control structures in there like for loops and while loops so that you can do a lot of repetition over and over and over. However, at the same time, it does not support object-oriented and the value and the benefits that object-oriented programming gives you. So most of blocks of code are stood off with braces. And those braces will give you a relation. So you'll see here we have a left and a right brace, and anything between there generally makes these statements as a group, and there's a relation in here. It's for control structures, for classes. Anytime you're trying to group your code together, you will use braces, and you can often nest those braces deeper and deeper, and you'll see that in some codes. Like you might have a while loop, and in the while loop you might have a for loop, or you might have an if statement. And those statements in the if statement, if a condition is met, do this. If you have an else statement, you have a separate set of braces, so that those just visually you could see your sequence of your relatable structures are in the same set. So again, here's this set here of braces. Everything in between it, is related. To get stuff out into the screen, you use the system.out. Now, this is the power of Java that really makes it, most programming languages, even C, there's a system here. This is the base Java system, and it has an out statement, and this will send data to the output device. Now, the nice thing about it is you don't have to write this. You don't have to write all the low-level machine code or all the low-level C or assembler code to kick something out onto the screen. So, if we have system.out.print or system.out.println, and you give it an expression, generally between quotes, then it will automatically take that expression and format it in such a way that it knows how to tell the CPU, hey, push this out to the screen. So you don't have to do that. It makes it really nice so that you can use without having to use the built-in functionality without having to write it yourself. If you had to write every single thing yourself, then it would become very, very tedious, and the language, you'd soon just want to give up on it, because now you've got to write it, how to get those characters out for every single one. Imagine kicking out a whole bunch of information to the screen. So that's where the power of Java, C++, C# comes in, is that you have a lot of these base classes where that heavy lifting has been done for you, that you can just invoke them, and that's what this is doing here. Your system out print line, you're invoking that, and it knows to pull that in to your program. It passes this variable to it, and then it lets it go out and handle printing things out to the screen, so you don't have to. So you'll notice here some different statements. We have 15 plus 10, and you'll notice here that this is adding it. So your output is 25. Now notice though that the output is a string, because in order to get information out, it converts it to a string. But this plus here is using a mathematical plus. The same thing here with I first num. We know that I first num is an integer value, and so we could say we want to add 15 to it, and that's the nice thing about variables. Right now we know it's 15, but an integer value in here can be changed. So if I first num was 15, then it's going to be 30. If it's 16, it's 31, etc. Notice here that we have this string, and we have a comma in here, and we have an exclamation point. Both of these are reserved. If you were to put an exclamation point outside of strings and not use it the correct way, it would actually throw an error. So because it's strings, it will throw this out as it is. And now we get a little fancier in here, this print line. Now the difference here between print and print line, by the way, is print will print it out on one line. Print line prints it out, and it's like hitting the enter key. It gives you a new line underneath it. So in this one here, system out print line, you'll notice here computer scientist, and then you'll notice you'll have this \n and have new memory. This is called an escape sequence, and there are a lot of escape sequences. You need to go out and look them up, but this one is the same thing as hitting the enter key. So if you did not have this \n in here and you type this out, it would put computer science have better memory all on one line out here. But there are ways to escape, or a new line in here, because you'll notice they hit new line down here, but that doesn't matter because it's still between the strings, so you have to tell it it's a new line. Then down here on the bottom, you'll notice here that we're addressing this variable name plus 15, and this is a string, and we know it's a string because you can see it's between double quotes. So even though we have a variable called I first name plus 15, which up here gave us 30, because it's in quotes, it puts that out exactly. So I first num plus 15 equals, and then you're going to notice we're concatenating a string, and then here's where we come down into precedence. Then we have this and this parenthesis, which means that this 15 plus first num, it knows that this is math. So when it goes to print this out, the very first thing it does is it does 15 plus first num, because it's in the parentheses because of order of precedence, takes that value, and because this value is 30, it's concatenated. It looks, oh, the first part's a string, the second part's an integer. Because it's a string, we're going to assume concatenation. Now C++ uses cout. Now this is where we start to see a difference between Java and we start to see a difference between C++. You look back here, you have to type system out print line, or if you include it, you have to type print line. Well, the thing about C++ is they use a lot of shortcut words. So in this case, cout, and it sends it to an output device. And you'll also notice that it uses redirect symbols, which is this right here. So instead of having to write all of this out here, system out print line parenthesis 15 plus 10 parenthesis semicolon, you get a little bit more compact statement. So you'll see cout, and then you want to output this 15 plus 10. Notice it's double quotes, so it's string, and then you're going to output the I result, which is a variable, and then you'll notice here that we have an end line. So it says here that it directs everything following here to define the output device. So in this case, we're going to cout this string, then this variable, which will convert it to a string on the back end, and then the end line. So if you look at that first one, cout 1510 end line, we get 25. The second one, we can use the cout, and we can use the variable in here, and that gives you the number. Now we have to use the end line in here because these are integer values. But you'll notice, look how more compact this is. Cout, your output redirect, and then here you have an n. There is no cout line. You have to give it this \n, otherwise, or this endl here. Otherwise, it's going to put everything on the same line. But this is where C++ is a little bit more concise, but requires you to have more intimate knowledge of the syntax, knowing that cout. And if you didn't know what cout is, and that's how it's pronounced, you would say, what's cout? I don't understand what cout is. So this is just part of understanding the C++ and when it was, come out in 1983, we didn't have as much memory as we do now, so things had a tendency to be a little bit abbreviated, but part of that abbreviation is more concise code. So now we want to input data. In Java, the class is called systemIn, but to get the information in, you use a scanner class, and that will read information coming in from the keyboard. Now, it will allow you to say this is a scanner of type char or type integer, but what it does is you create a local variable in your program to hold that value as it comes in. So it says it places them in another variable acting as a buffer for storing the entered string. And then to get that, after you do your systemIn and your scanner, then you say give me the next value. Now that's a little bit more verbose, but it's easier to read. Whereas C++ you have cin to do that. So we're going to look at some control structures here. So in Java and C++, invocation is used by calling functions and methods, and that's pretty much the same in Python and C# as well. A function, and there's a difference here, a function performs a task that can return a value. It doesn't have to return a value. If it doesn't return a value, you generally have a void, which means that as you call this function and it sees that it's a void, there's nothing to return back. It's going to go off and do some calculation on its own, whatever it's going to do. A method is similar to a function, but it's in a class. And there's a difference there. A class is generally an external code. Could be a Java file, or it could be a C or a header file that allows you to take that information and call it multiple times for multiple locations and use it in that class in different programs. Generally, the function itself is within the program that's calling it. So it's not as flexible outside of the program, but that function can still service the whole program. So in order to do that, use the equals method, and you can control code associated with equals, and it carries out the statements, it makes a comparison, it returns a Boolean. So that's one way that you can use this method here. This method belongs to a class, so in order to use that, you generally have to import that class. It's often, I think it's part of the system class, so it's there by default, but it's still in an external class. But you can pass code to it by invoking it, pass in some variables, and see what the return value is. So selection, again, this is where I deviate here. I'm not a big fan of pseudocode. To me, if I'm going to write pseudocode, I might as well write the code. Today, it seems awkward to write all this pseudocode. Again, going back to the software engineering module, create yourself a flowchart, use that flowchart as a map, and then write the code for it. So this claims that it will ensure the program meets the language requirements, and in chapter 14 there was some templates for writing that. Again, you can look at the code on 531 to 533. I'm not a big fan of pseudocode. I figure if you're going to write pseudocode, you might as well just write the code. So here, let's talk about some powerful. You have an if statement, which an if statement only acts on true. So if this condition is true, and then you'll notice here the brace, anything in between these braces are statements that can run if the condition is true. So it's important to know if only executes if this condition, which is generally in parentheses here, is true. If it's not true, then it won't execute. If you're going to use if and else statements, now you have a true and a false. So now you could say, if this condition, then these statements will execute. Otherwise, it's false. So if it's true, do this. else, if it's false, do this. Notice that the if true conditions are between these braces and the false conditions are between these braces, and it can be one or more, and notice they're always separated or terminated, with a semicolon. And you can use if and else if statements as well for multiple true conditions if you want. Just remember, if is only if it's true is it executed. If else will give execution if it's true, or perform some other code if it's false. Very common in programming to use these conditions, because depending on what those variables or what your conditions are depends on how the program's going to execute. And then again here, if and else if statement. It says here it corrects the problem if else statement if the enter uses an incorrect input value. But it will, depending on what your else if statements are, you can execute various blocks of code depending on their input. Now, if you start getting into if else if statements and start getting into multiple else if statements, there's better ways to, they call refactor your code or structure it. But depending on what the variable is, you can have multiple blocks of code execute depending on what that is. It says here, it makes it more flexible, because now you can say, well, I don't care if it's true or false. If it's not this, then check for this or this or this, and eventually you get down to an else statement, which is false, saying if it's not any of these, then take this action. Now, a switch statement, well, is what I was talking about, kind of alluding to here on your if else if statements. This allows you to have multiple statements that could test whether a value is met. Now, there are some problems with switch statements. If you have nesting, as they say, where you put one control structure, if, and then in that if statement you have another if statement and another one, and you nest it, it becomes really ugly to use, and it really becomes harder to debug getting into those inner statements. So you can use switch, will allow, it's a lot easier to read, and you can execute your block. The problem is that you have to have a scalar data type in order for these expressions to be true. So if we take a look at this switch statement here, here's the expression. So this is what we're going to switch on. So if we pass an expression, you'll notice that we have a case statement. All of these really should, as it says here, syntax alignment, all these case statements here should be moved over. So, forgive the formatting on this. But with a statement here, you have this value. If this value is true, now you'll notice it kind of breaks it a little. The switch statement is between these two braces here, but the cases themselves follow the colon, and then you could have multiple statements in here, and then you break out here of the switch statement. And so if you have this, if you have a case, the default here, if all of these, if it's not, value 1, 2, or 3, then the default you have a fourth statement. You should always have a default in your switch if none of these conditions are true. And so what happens is it performs to quit processing here on the break statement and send it down to the end of the switch statement, which is right here. Now this is what we talked about before in the software engineering and last chapter. This is where computers really excel, is in looping. They could do the same thing over and over and over without becoming bored, without making errors. Most of your gaming consoles out there, all a game is a giant loop. While the person's playing, while they haven't died, while some condition is meant to stop the game, it just continues going over and over and over, and allows you to do the same thing without having to type that statement over and over. There's three general statements. We have a for, while, and do while. And there are subtle changes in here that we'll talk about. Now the for statement is if you, and there's another one in here that we don't really talk about in this class, and I don't think they do in CS 1400. There's another one called a for each, which allows you to iterate over a collection. So for instance, if you have an array and you have 20 items in that array, a for each loop will go over each item in that loop without going past the end of the loop. It's kind of a nice thing to have. So if you have a number of times that you want to execute a statement, then you use a for loop. And you can see down here for, and you declare the variable and then the expression that you're going to check, and then you increment or decrement that, and then again, here's your condition in the parentheses, your braces here, all your statements that are going to happen every single time you go through this for loop. Sorry about that. So it is possible to say for, and you can declare a variable, int I equals 0, and you could say while I is less than 10, then you can take some statements in here. We'll repeat that 9 times, and because you declare it as 0 to 9, it'll be 10 times. This is a way to execute a specific number of steps. Now, if you don't know if you have a certain number of steps, then you can use a while loop. It is like a for loop, and we'll talk about the difference here between while and do while, but there's a precondition to get into the loop. So you check for a condition. If that condition is met, then you jump into that loop. Notice here, it may never be executed. Now, one thing that happens in a for loop here is part of the declaration of the for loop. You increment or decrement your counter so you know it's going to execute a specific number of times. A while loop doesn't have that condition, so you have to check that condition or set the condition to be false to get out of the while loop. If you don't do that and you forget to check that condition, you can get into what they call an infinite loop, in which it will just continue your process over and over until it runs out of memory or just keeps going. So you have this while and you have an expression. So your expression might be x is less than 10. Then you have a statement in here, do some work. But you need to make sure in this while loop, between this brace and this brace, that this expression gets modified in such a way that you're able to get out of the while loop. So if we have while x is less than 10, do this statement, you want to make sure that you increment x in such a way that as it goes back up to the while, that expression either is true or false. If you don't put that modification in there, these statements will just execute forever. Now, do while is based on an expression after. So the big thing here with this post condition loop is that it executes one time before it's evaluated. While statement may never be executed, because if this expression never evaluates to true, these statements do not perform. A do while loop guarantees that at least one iteration of the loop will execute. So it comes in here, here's our braces, so here's our statements, but you'll notice here that, again, the while is before to get into the statements. Do will automatically perform these statements and then check the expression afterward. So much like the while loop, the do loop requires you to modify the expression in some way so that you can break out of the do loop. Also, again, this is one time, and I believe there's a test question on there that which loop will execute at least once regardless of the condition, and that is a do while loop. So a couple of last thoughts here, and again, we didn't go into heavy programming in here, we just kind of gave a little bit of a overview on some of the things that can happen. Most programming languages use these control structures that we talked about, for, if, while, etc. The big one here is organizations select the programming language based on the application's needs. There's no one language that is better than any other. Each language has its strong points, and there are languages that are suitable to do multiple things. So don't get so caught up in the dogma of I have to use this language, when really any language that's suitable will probably work. Now you just need to make sure of that. I wouldn't want to write a program in assembly. That would be a long, tedious process, but it would be fast. So depending on what your organization needs, if you're again getting into electrical engineering or any of those low-level programming, you're probably going to be an assembler in C. You need to keep your skills up to date. It says C++, Java is a good start. I'd also say that C# and Python are good starts as well. Swift and Object-C may be a little bit more advanced. Rust is that same thing. But really, you want to get a language, Java, C++, C#, Python, practice. Remember, practice, practice, practice. And it's best to have a solution that you're developing for. It's really hard to just go out and read manuals and type in the tests, the sample code they give, if you don't have an endpoint. Because what'll happen is you'll do that and walk away and lose everything. If you do have an endpoint, if you do have a goal, if you do have a solution that you can solve with software, that's a better place to start than just saying, I want to learn this language. Now again, the open source community out there has plenty of places that you can jump in, tell everybody you're a novice developer, and they'll help you along so you can learn the language and program to an end goal. Remember that software engineer has the responsibility to write easy to read and easy to maintain structured programs. Often you are not the only person who will be messing in this program, especially if you're working in a company. Know that the cleaner code that you write, the better code you write, you're doing yourself a favor first. If you have to go back and support that code later, it's easier to look at the code that is written well and structured well than looking at spaghetti code. And also, if you're working with other team members, it is imperative that you write code that's structured so that you guys can, as a team, become more efficient. So Java, C#, designed for the internet. C# wasn't, but Java was. But both of those languages have since matured and become languages that enterprise systems are written on. Both of them very mature, good languages to learn. Big job base for both of them. C++ is a higher level. It's object-oriented C, and so it does bring in the niceties of object-oriented aspects, but it still kind of maintains the speed that C had because it is compiled where Java and C# are interpreted. Know that you have different variable types. We talked about a few: integers, characters, floating points, etc. That when you create a variable, it needs to be initialized. Now by default, the program will create it, so if you create an integer and don't give it a value, but you give it a name, it will initialize that to the default value, which is generally 0. For string, it may be an empty string or an empty character. But like I said, don't rely on the default values. If you're going to declare a variable, first of all, make sure you need it, of course. But if you're going to declare a variable, then initialize it or set the value quickly so that you can ensure that the value is what you're expecting. Now, I do know in Visual Studio, if you declare a variable and you never use that variable, it will flag it so that you can get rid of those unused variables, and I'm sure other development systems do that as well. We talked about the control structures. Invocation, which again is object-oriented, but it's calling a function within the program, or a method, which is an external object or class. This is where object-oriented programming comes in. If you find yourself using the same code over and over and over, it's a good time to use invocation. Whether you're going to call a function within the program or an external method, there's no reason to have the same code everywhere. We had top-down, which was more of a procedural language like C. It starts at the top, goes to the bottom. Selection, which uses the if-then statements, and then repetition, which is loops. Java uses methods for invocation, and C++ uses methods and functions. The difference between a method and a function, again, is that a method is within the the same program, a function is in an outside object. A couple examples was Java uses C system out, where C++ uses C out. It's a little bit more concise. So, I would suggest if you're going to start programming and haven't cut your teeth on anything, Java and C# would be the way to go, and then look at C++ once you have your foundation and footing set, because then you can understand the principles and know that C++ you're going to concentrate a lot on syntax because a lot of it's shortened. Java uses a scanner class, C++ uses cin. We talked about our control structures here: if, else if, and switch. And remember, switch can only be used with scalar values, or variables, excuse me. Repetition, we had for, which will give you, I want to execute this for a specific number of times. You have a while loop, which may never execute. If the expression is evaluated to false, it will not execute a while loop. A do loop guarantees that it executes once, then it checks the condition. And in the while and do while, you need to make sure that you put code in there that modifies that expression to keep it either true or false, otherwise you'll get into an infinite loop. And then last but not least, like we said, over and over and over, practice, practice, and more practice. So that sums it up for developing. Again, thanks for your time, and if you have any questions, go ahead and contact me.